All right, so we're finding the least common multiple of these polynomials. So if you remember back, we were able to find least common multiples of just plain old numbers, and then we looked at finding the least common multiples of polynomials. So the first thing we're going to do is we're going to go ahead and factor these so we can figure out what factors they have in common and what they don't. So this one factors to x minus 6 and x minus 1. And this one factors to x minus 3 and x minus 2 because that multiplies to 6 and adds to negative 5. So then the question is, what's the least common multiple of these? So we can, if you'd like to, draw a Venn diagram, and we can see what do they share. Well, actually, these ones don't share anything. So they have x minus 6 right there, and x minus 1. Ooh, that one's not so pretty. And then there's x minus 3 and x minus 2. And since they don't share anything, there's nothing in the middle. So what is the least common multiple of these? Well, it's x minus 6 times x minus 1 times x minus 3 times x minus 2. It's just everything multiplied together. So if this was a denominator of a fraction, that's what our least common denominator would be. Let's take a look at the next one. What's the least common multiple of these two? So let's factor them out. So what multiplies to negative 24 and adds to 2? It's going to be 6 and 4. So x minus 4 and x plus 6 gives us negative 24 and adds to positive 2. And then this is the difference of squares. So we have x minus 4 and x plus 4. And then there's a third one there, if you notice that. What's the factors of that? Well, it's 2 and y. Okay, so let's see what they have in common and what they don't. Now, a Venn diagram could hypothetically work here, but it's a little bit more challenging. So let's see if we can just use our knowledge of Venn diagrams to figure this out. Okay, so let's start with what any of them share, right? What is anything that they have in common? Well, these two have x minus 4 in common, so we can just take one of the x minus 4s and it takes care of both of them. And then do they have anything else in common? I don't see anything else. So the next one would be x plus 6. We got to use that one. We got to use x plus 4. Okay, we got that. We got to use 2, and we got to use y. And so this is the least common multiple of those 3 altogether. So if we had 3 fractions we were adding together, this would be our least common denominator. So let's find the sum of these fractions. So the first thing we got to do is find their least common denominator. So let's just go ahead and factor top and bottom. That's the difference of squares on the bottom. So we've got x minus 1 and x plus 1. And then we add 2 plus, and this is x plus 2. Oh, not plus 2. We're going to do minus 2. And x minus 1, because those would multiply to positive 2 and add to negative 3. So what is our least common denominator? Well, what do they have in common? They both have an x minus 1. So our least common denominator, and I'll go ahead and write it right here if I think I have room, is going to be x minus 1. That's what they have in common, right? And then we need every other factor as well. So we're going to have x plus 1, and we're going to have x minus 2. So that's what our least common denominator is going to be. So let's look at this first fraction. What do we need to multiply the top and bottom by? And we could even look at this one since it's factored. What do we need to multiply top and bottom by to get it to our least common denominator? Well, the only thing it's missing is the x minus 2, right? So we need to multiply the top and bottom by x minus 2. And so we're going to end up with x minus 2 times x plus 3 all over our common denominator, which is x minus 2 times x minus 1 times x plus 1. And then what is missing on the other one? Well, it has an x minus 2, it has an x minus 1, it just needs an x plus 1. So we're going to multiply top and bottom by x plus 1. So we're going to end up with 2 times x plus 1 on top, and on bottom we're going to have x minus 2 times x minus 1 times x plus 1. So now, since these two fractions have the same denominator, we can actually multiply, or sorry, not multiply, we can add them together, right? So we take x minus 2 times x plus 3 plus 2 times x plus 1, and that's all going to be over x minus 2 times x minus 1 times x plus 1. Now, you might think, oh, I bet we're done, but we're not quite, because that top is like, it's not all multiplied together, right? It's not actually factored. It's like two separate terms. So we have to simplify it some more. So we're going to go ahead and multiply some things together. So we're going to start by multiplying that out. You can use FOIL if you'd like, or you can use a box method. But that becomes x squared plus x minus 6. And then we're going to multiply this, and that just distributes, right? 2 times x and 2 times 1. So we have 2x plus 2 all over x minus 2 times x minus 1 times x plus 1. And then we combine things that are alike. So we have x squared plus 3x minus 4 all over that. I'm just going to go ahead and do that right now because we're going to write it again in a minute. So let's factor x squared plus 3 minus 4. That's going to be x plus 4 and x minus 1. And that's all over x minus 2 times x minus 1. And do you see why we needed to go that extra step? Why we couldn't just leave it in this green form up here? Because do you see that actually in the end, there's an x minus 1 on top and bottom? What? So our final answer here, if we add those two functions together, is x plus 4 over x minus 2 times x plus 1. So that's adding rational expressions. Now let's see if we can just try subtracting. So we're going to go ahead and skip on to this one. We're going to find the difference between the two. And you might look at it and be like, yay, the tops are the same. But remember, it doesn't matter what the tops are. We got to look at the denominators. We got to look at the bottom. So let's go ahead and factor these. So on top we have x plus 1. Multiplies to 16 and adds to negative 6. That's going to be x minus 8 and x plus 2. Okay, then we're subtracting x plus 1 over what's going to multiply to 8 and add to 6. That's going to be x plus 4 and x plus 2. So what's our common denominator? Well, we have an x plus 2 on both of them, so they share that. So if you wanted to draw a Venn diagram, you could to remember that. In fact, we can do that up here. Our Venn diagram, they share x plus 2, and they do not share x minus 8 and x plus 4, right? That one belongs, x plus 4 belongs to this function on the right, and this belongs to the function on the left. So when we want to figure out what our common denominator is, we just multiply all of those factors together. So we're going to end up with our denominator is going to be x minus 8 times x plus 2 times x plus 4 minus, and then our same denominator, x minus 8 times x plus 2 times x plus 4. So then we look at our functions and we say, okay, what is the left one? What's it missing? What does it not have on the bottom yet? Well, it needs an x plus 4 on the bottom, right? So if we multiply the bottom by x plus 4, we also have to multiply the top by x plus 4. So we end up with x plus 4 times x plus 1 on the top. And then we look at our right function. We say, what is it missing? Well, it's missing an x minus 8. So we want an x minus 8 on that one. So we go x minus 8 over x minus 8. So we end up on the top with x plus 1 times x minus 8. And now we go ahead and just do some math. And there's two ways to do this. We can just subtract right now, or we can multiply everything out and subtract. The key is we want to remember that we're subtracting, because that means everything over here gets subtracted, right? So let's go ahead and just subtract right now. So we have x plus 4 times x plus 1 minus everything on the top here. So that's x plus 1 times x minus 8, right? All over x minus 8 times x plus 2 times x plus 4. Since they're adding or subtracting together, we keep the common denominator, okay? Now we're going to go ahead and expand by multiplying these two together and then multiplying these two together, because see, I can't just go ahead and cancel, because that would be canceling across addition or subtraction, and that's when we kill kitties, right? Can't kill any kitties. So there's not an x plus 4 in every single term, which tells me I cannot divide it from the bottom and the top. So I got to go ahead and start expanding. So I'm going to multiply these, and you can use the box or foil, but it's going to be x squared plus 5x plus 4. And I know you're like, what? How fast did you do that? Well, just remember that, you know, I do this for a living. So I subtract and I multiply and I FOIL a lot. So it's okay if it took you a minute to multiply those out. Okay, so then we're going to subtract, and remember, we're going to subtract whatever this whole thing is multiplied together, right? We're going to multiply both of those, and we're going to subtract all of it. So I'm going to go ahead and put parentheses there, just so that I remember I'm subtracting everything. So I'm going to get x squared minus 7x minus 8 all over our common denominator. And then we're going to combine things that are the same. Now remember, since I'm subtracting right here, since this is a subtraction sign, it's going to subtract every single term inside those parentheses. So I'm subtracting x squared, I'm subtracting a negative 7, and I'm subtracting a negative 8. So let's just rewrite this without those parentheses. So we have x squared plus 5x plus 4 minus x squared minus negative 7, which is actually plus negative 7x, and minus negative 8, which is actually plus 8, all over our common denominator. Okay, so now we're going to go ahead and combine things that are the same. And we get that x squared minus x squared is actually 0. So then we have 5x plus 7x, which gives us 12x. And we get 8 plus 4, which is 12, over x minus 8 times x plus 2 times x plus 4. And we're so close to being done, but we notice that the top has a common factor. So then we go ahead and factor that out, and we get 12 times x plus 1. And it looks like this one does not actually have anything that cancels out. So we did all that extra work for nothing. No, we did not. We have to do this every time, even if it doesn't factor out. So we see that that's our final answer. And that is actually a lot easier to put things into than any other function that we've seen so far, right? If we want to evaluate this function at 2, it'd be really easy to just put 2 in there. So there you go. That is the long and the short version of how to add and subtract rational expressions.